Yo, what's up, YouTube? It's your boy. Crack your thumb, innit? And, yeah, I have to write my laboratory journal. I have to start doing this. Pop, pop. Mm. Oh, planning to do a lot of shit and I need to make a YouTube video. I need to think of a YouTube video explaining why you, you, why you should subscribe to this channel. I still haven't figured it out, but I need to make one. What else? Yep, lab journal. What's it? For a second, I forgot what I should be doing. Oh, dude. It's scary. It's a real scary stuff. It's a very scary stuff. Know what I'm saying? It's very scary. So, first I have to write section 1 and section 3. Recrystallization, filtration, and sublimation. Sublimation. Introductory lab course. Is there any, what is it? Drawing. I should read these. I know. How many pages is it? 55. I'll read it. And I need to confirm. Josh Johnson. How can I play football on your forehead? Bro, okay, I'll tell you one thing. We see vehicles with, there are 500cc cars, there are cars with 1000cc, and then there is Ferraris, Lamborghinis with V12s, V10s. This is a V12 up here. That's the difference. That's the fucking difference, Mike. Stop. Shut the fuck. Accent is falling apart. Well, fuck you, man. Fuck you. What are you up to, man? Are you still on the stream, or did I just curse for nothing? No, this guy's not on the stream. Well, that was a waste of time. Where is this? Where Moodle? Login. Where, touching me, touching myself. You what, bro? Just, just kill yourself, man. just, just end this. End. Also, I got results for my physics exam, and guess what? I failed. Did you expect that? Now I know, right? It's weird. Sky is worth. Where is the Moodle page? Section 1 and 3. Yeah. Let's start doing this. Not the instructions. Yo, GPT, I have to write my lab journal, and these are the first two experiments I have to write on my lab. I'm going to. You, bro, this is a YouTube account. This is an official YouTube account that I'm using to record my studies. And you fucking piece of shit. You just wrote stuff like this. What? Dude, you could have written, good luck on the lab journal. You could have written that. No. No. What can I do to remove such comments? Mm-hmm. No. Uh. Okay, that's weird. Mm-hmm. I cannot delete a comment? Well, it's what it is. Section 1. Just copy that. This is section 1. Mm-hmm. In section 1, what was the... Yeah. My working place number is 404, okay. Laboratory service, that's different. This catch-up day. Oh, it's the catch-up day. I don't need the catch-up. I'm just gonna do it. Section 1. I start with part 3. Also, from my section. The YouTube comments are so slow, but that doesn't change the fact that you wrote some bullshit up here. Thanks, that is really helpful. Okay, part 3, preparation of the indicator solution. 1 gram of metal orange are weighed using a balance. Also, about the YouTube comments being slow, I changed the streaming platform from Google Chrome to OBS. So, yeah, it's going to be a bit slow from the real time, from the time you type to the time you display, time it displays. 0.1 grams of metal orange was weighed using balance transferred to hard transfer to 100 volumetric flask. It is dissolved in distilled water, and the solution is made up to a mark, 100 milliliters mark. Okay. Oh, what? So part 5. Where's modal? Part 3. I start with volume change during preparation. Prepare a binary solution. Weighing, titration. No. Part 3. Part 4. Part 4 and 5. And at last, part 1. Okay, I did not put part 2. Why? Mm-hmm. And at last, part one. It is very interesting to do this. Choose two immiscible liquids, measure certain volume for each, say 100, separately using a graduated cylinder. Why is the value not given? Okay, that's bullshit. Uh, we recommend practice how to read the scale. Therefore, we prepare a Moodle test for practicing purpose. You can repeat it as often as you want. You find it together with various videos about the practical task in the practical work section of the Moodle. Okay. Measure a certain volume. Here it's water and acetone. Okay, yeah, it's section 1. Uh-huh. 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 Measure a certain volume of each. Pour both into another graduated cylinder. Record the final volume. What to observe. The final volume must not be exactly 20 milliliters because mixing causes molecules to rearrange, leading to contraction, especially with water and ethanol. This part is quick but requires careful reading of meniscus and using a clean dry filter. Prepare a binary solution and measure its volume and mass. Measure the required volumes of water and acetone with graduated cylinder. Mix the two liquids thoroughly and measure the mass and volume of the mixture using graduated cylinder. Why is the numbers? Volume measurements. Until 11. I have 6th of July. Oh, tomorrow. Fuck me. It's script theory procedures. Last update. That should be the same as. No, it's new. Oh, the working place number still don't make sense. prepare a binary solution. Measure the required volumes of water and acetone in a graduated mix. Two liquids thoroughly and measure the mass and volume of the mixture using a graduated cylinder. Hand in the prepared solution in a properly closed 250 milliliters Pyrex bottle and label the bottle with your group and working place as well as content, example X percentage or X milliliters, and date of preparation. Okay, the first experiment looks pretty easy. Pretty easy. No, I'm done with this. Okay, the first experiment looks pretty easy. Pretty easy. So I got the part 3, now part 4, only weighing and dissolving sugar solution preparation. Goal, prepare a sugar solution with known concentration. Whoa, what happened, dude? You good? Known concentration. Weigh about 1 gram of sucrose on an analytical balance. Transfer the sugar into 25 milliliters volumetric flask using a funnel or clean paper. Add a bit of distilled water. Swirl until the sugar completely dissolves. Add a bit of top up with the distilled water exactly up to 25 milliliter mark. Bottom of the meniscus touching the mark. What is a meniscus? I don't know. Stop here for now. You will do the density measurement later. What to focus on? Sugar must be completely dissolved before topping to the mark. Use a pipette slash dropper for fine adjustments near the mark. Make sure there are no air bubbles or undissolved particles. Okay. Part 2, measurement of the volumes. Practicing using different volumetric tools and compare their precision. What you'll do, measure the same volume of water using graduated cylinder, pipette, burette. Transfer the measured water into small beaker and weigh in to calculate the volume. Using water density. Do this multiple times, like 3 times each, to check accuracy and reproducibility. Avoid parallax error when reading the meniscus. Make sure the instruments are clean and dry. For puppets and burettes, watch for air bubbles in the tip. That's it. Yeah. Finish part 4, density of the sugar solution. Calculate the density of the sugar solution you made earlier. What you'll do, weigh an empty dry pinometer, I don't know, a glass device with precise volume, often 10 milliliters. Fill in with the sugar solution up to the calibrated mark. Wipe outside dry, then weigh again. Subtract to find mass of the sugar solution. Subtract to find mass of the sugar solution. Divide by the volume of the picometer. Density equals mass by volume. What to watch for? Avoid air bubbles in the picometer. I don't know. And make sure it's completely filled and capillary hole is clean and unblocked. Okay. Okay. Now part 5, sugar content in a beverage. Use density to estimate sugar content in a soft drink. Open the drink, stir to remove bubbles, fill and weigh the picometer as in part 4, calculate the density, use the lab's reference table or chart to look up the sugar content. I don't think this is about. I think you have to use the refractometer. But you're not talking about part 1. Use lab reference table to look at convert sugar content. No, you're not talking about refractive index. You did not even. Now, part 1, single versus multiple extraction. See which method removes more of the colored solute from water using organic solvent. Solute from water. Okay. I'm gonna take it to the down. Nah. Just to keep it to the top bottom, yeah. Take a colored aqueous solution, example methylene blue or iodine in water. Stop saying example, you know there should be one in the book. The biphasic mixture. The funnel is closed with the stopper and turned upside down and shaken a few times. After every shaking, the outlet is opened to release pressure. Then the separating funnel is fumed again. It's turned again. Oh, fuck me. Turned again. After two faces have separated, the stopper is removed and the lower face is slowly removed via the outlet, collecting in a labeled beaker or uh, whatever flask. Then upper face is removed through the outlet and collected in another labeled beaker for multiple extraction. The face that has to be extracted is poured back into the separating funnel, and the opposite is added in procedures described. I need to see video on this. I remember doing this, but you know, you can still try again. You could still try again. What?
Ein echter Jackpot. Zu A1 Internet gibt's jetzt ein Geschenk nach Wahl.
Hi everyone, my name is Lisa Nichols, and in this video I'm going to show you how to do multiple extractions. This is a follow-up from a previous video where I just did a single extraction, and I took a pink methyl red aqueous solution and extracted it into ethyl acetate and separated it using a separatory funnel, and was able to get these two different layers, a top organic layer and a bottom aqueous layer. So this is where I ended in the last video. I had the methyl red mostly extracted into the top layer, making it orange, and the bottom layer looked pretty clear, so there weren't as many methyl red molecules left. But you know, there really could be some left, and not everything is going to have the same sort of distribution as methyl red. So in that case, you might want to do a multiple extraction. The whole idea is that there are still molecules left in that bottom layer, and can we get more of them out? You're basically going to do that extraction again. So here's what you're going to do. Let's bring in some new ethyl acetate. And you're going to take that bottom layer, which in this case was an aqueous layer, and we're going to put it back into the separatory funnel. Again, the goal is to try to get more molecules out of it. Use the funnel again, and I pour my aqueous layer or my bottom layer back into the original separatory funnel. There's no need to clean the funnel in between a first extraction and a second one. It's all the same stuff still. So I pour my bottom layer in, and then here's a fresh ethyl acetate portion. And I shake up the separatory funnel just like I did in the previous video.
Shake and let the gas out. Yeah, I remember.
And I turn it upside down, use two hands, give it a little vent, and give it a good shake. Between 10 and 20 seconds.
10 seconds? I thought it was 3 or...
That's probably good. And now I let it settle down and let the layers form. Now here's something interesting. I think if you look at that top layer, I think it has a tinge of yellow in it. Don't you think? So that means that there were methyl red molecules still left in the bottom layer that by adding fresh ethyl acetate, I was able to extract into the top layer.
Yeah. Hell
So
yeah.
I did get a better yield of my methyl red. After that second extraction, now you want to separate the layers, which you do in the same way as before. Take off the stopper, drain out the bottom layer, stopping when the interface is right in the stopcock. I go a little slower as it nears, and then I stop right there. Stop. And then I'm going to pour out the top layer, and in this case, I can just combine it with my previous top layer, because the goal normally is to try to pull molecules into that top layer as much as possible. So they're all the same thing, so you may as well combine them together. And that would be 2 extractions. Sometimes you do 3 extractions, but that's the general idea of multiple extractions.
Pour it again.
Using the right weight.
Ethyl acetate. Shake it, shake it. Get it? I get it.
Professor Dave here. Let's talk about extraction. He knows a lot about the science. Water and sand. You can just use some filter paper, and the smaller water molecules will pass through the tiny pores of the paper, while the larger sand particles will not. But what if we have a mixture with several substances that are all small molecules? Particle size will not be of any help here. Instead, we can make use of certain physical properties, like solubility, or even chemical properties, like some specific type of reactivity. A technique we can use to do this is called extraction. So let's learn how to do this now. Let's say we have a mixture of sodium chloride and cholesterol. These are both white crystalline solids, so if mixed together, it may seem impossible to get them separated again. But in fact, we can use their physical properties to separate them with ease. Sodium chloride is an ionic compound that is water soluble. Cholesterol, on the other hand, is a steroid, which is a type of lipid and is therefore non-polar and largely water insoluble. However, cholesterol will easily dissolve in a non-polar solvent, like ether. So to separate this mixture, we would just toss in some water and then some ether. We swirl it around for a while and then put everything in something called a separatory funnel. Since these two solvents are
The organic compound, the fat stays up, the
miscible,
water,
meaning they do not
sodium
mix,
chloride
we will
stays
get
down.
2 layers. On the bottom will be an aqueous layer, which contains all the water and all the sodium chloride, which has dissolved and dissociated in the water. On top will be an organic layer, which contains all the ether and all the cholesterol, which has dissolved in the ether. The water is on the bottom because it is more dense than the ether. So we just open up the funnel and drain the aqueous layer until we just barely get to the organic layer. And then we pour that out the top of the funnel into something else. Evaporate the solvents, and there you have your substances, nice and separated. That one was pretty easy because the substances had differing solubilities.
Yeah.
Now let's look at a trickier example. Say we have a solid mixture of 4-chloroaniline, benzoic acid, and 1,4-dibromobenzene. These are structurally similar and therefore have very similar solubilities, so we can't just use 2 different solvents and expect much to happen. Instead, we have to do some chemistry. Let's toss the mixture in a flask and dissolve it in ether, and then transfer over to our separatory funnel. Now let's think, is there something
what you do?
just use 2 different similar and therefore have very similar solubilities, so we can't just use 2 different solvents and expect much to happen.
Yeah.
Instead, we have to do some chemistry. Let's toss the mixture in a flask and dissolve it in ether, and then transfer over to our separatory funnel. Now let's think, is there some type of reaction that only one of these compounds might undergo that the others would not? Well, 4-chloroaniline is somewhat basic because of this amino group. Benzoic acid, as the name suggests, is acidic. And dibromobenzene is neither. So what if we do some acid-base reactions? Starting with the aniline, this will react with a strong acid, like hydrochloric acid, while neither of the other two compounds will react, since they are not at all basic. So let's toss in some of an aqueous HCl solution.
Das Monday Sales CRM ist
Bro, come on.
definitiv das beste CRM, mit dem ich je gearbeitet habe. Seitdem wir das Monday
Since this is aqueous, it will be more dense than the ether, and it will pass right through to collect on the bottom, forming an aqueous layer. But as it passes through, it will perform acid-base reactions, transferring protons to all the aniline molecules. Once aniline is protonated, the nitrogen atom will bear a formal positive charge. And whereas the neutral aniline was not particularly water-soluble, this aniline salt will be, because the formal charge can make ion-dipole interactions with water that are favorable. So it's as though the acid yanks the aniline into the aqueous layer as it passes through. Just to make sure everything reacts properly, we will put a stopper over the funnel, pick it up, and shake it around a bit. This will generate some pressure inside the funnel, so we will have to periodically vent by holding it upside down with a finger on the stopper and turning the stopcock to release the gas that builds up. This will produce an audible sound. Then close the stopcock and shake some more, and then vent again. You can keep doing this until the venting doesn't make any more noise. Then you know it's done. Then just drain the aqueous layer into a new labeled flask. To be thorough, we will typically wash the organic layer again with another portion of the acid and repeat the whole process, and then maybe even one more time with just deionized water, collecting all 3 aqueous extracts in the same flask. Now we've got our aniline salt sitting in water, and we can put it aside for a moment. So what's left in the ether? There is benzoic acid, and there is dibromobenzene. As you might guess, the next step will be to add some base, since the acid will react, while the other compound will not, since it is not remotely acidic. So we can add some aqueous sodium bicarbonate, which will pass through the organic layer to form an aqueous layer at the bottom. But as it goes, it will accept a proton from benzoic acid. This leaves the benzoate ion, which will be very water-soluble, since the negative charge can interact with water molecules in solution.
Both positive and negative.
So just like the previous step, the base drags benzoic acid into the aqueous layer. We perform the same actions as before, shaking, venting, collecting the aqueous layer in another labeled flask, washing again with base, and then again with just water. And now we have our benzoic acid salt sitting in water, which we can put aside. So what's left in the separatory funnel? That will just be the dibromobenzene in ether, and we can pour that out the top to avoid contamination into yet another new labeled flask. Wash the empty funnel with a little ether to make sure we get it all, and add that to the flask. Now toss in a little bit of a drying agent like sodium sulfate to suck up any water that may have made it in there. Then use a funnel with some filter paper to transfer the solution into yet another flask, this time pre-weighed if you intend to measure the mass of product. So now we have successfully separated our mixture into its 3 components. So how do we get the solids back? Well, the dibromobenzene is easy. That's just sitting in ether, and ether is quite volatile. So let's just put it on a hot plate and use a low setting to gently evaporate the ether away. The dibromobenzene will remain as a residue, and you can weigh the flask again to get its mass. The other 2 substances will be a little tricky because they are now salts, so we have to do a little more chemistry. The aniline salt needs to be deprotonated, so we need a strong base, like sodium hydroxide. Let's add some of it to the flask, immerse it in a cold water bath, and watch the 4-chloroaniline precipitate. We can be sure that this is finished by checking the pH. Once all the salt has reacted, then no more hydroxide can react, and it will thus remain in solution, and the pH should reflect that, reaching around 11 or 12. Now that we have our solids sitting at the bottom, we can just set up a Buchner funnel, hook it up to a vacuum pump, pour the solution onto the filter paper sitting in the funnel, and wait for it to dry. Then we can do the same thing with the benzoic acid salt, except here we need a strong acid to protonate it. So to this flask, let's add some HCl, watch benzoic acid precipitate, check for a pH of around 2 to ensure that this is complete, and then collect that in a Buchner funnel as well. And there you have your 3 solids completely separated. So hopefully we now understand what extraction is and how it is performed. This technique is ubiquitous in the organic chemistry laboratory. Almost every single time a reaction is performed, it will end with some kind of aqueous workup to neutralize any ionic products, after which the contents of the reaction flask will be transferred to a separatory funnel for extraction. So if you are interested in doing a lot of organic chemistry, make good friends with your separatory funnel now. And with this technique understood, let's move forward and learn about some others. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon.
Bro, I wish I had the money to support. Well, that's it, people. So that's the whole point of extraction. And what type of compounds are we using? Biphasic, water, and organic solvent. So the organic solvent would be, you know, type of lipid or whatever. It should be in the top of the separating funnel. Or it's a separating funnel, right? Yeah. Okay. Whew. Dude, where's my watch? Oh no, did I kept it on the shower? I'll be right back, people. Oh, was here. Little bastard scared me. Do you have batteries? No, gotta charge. I'm hungry, bro. I'm not hungry. I just don't feel good. Just don't feel like I'm eating healthy. You know what I'm saying? Well, today push-ups. That's gonna be happening. Push-ups. So, starting with, I need a scale. I need a big bad boy scale. Oh, God, there's one more scale up here. use this. God damn it. God damn, boy. I had some amazing pens. Dude. Oh, you can't see that. Doesn't matter. Come on, I did have a bigger scale. Ah, where is it? Where is it? Fobistu. Oh well. Guess I gotta break this packet. It's a new scale. I don't wanna use this. Come on. Ain't got no time to waste. I'm starting with section 1 and 3, right? Yeah, section 1 and 3. So, section 1, extraction and measurements of volume. I don't know, 1, 2. So how did you start? Equipments, objective. So there should be a exemplar lab journal, table of contents, literature, chemicals. Okay, so these handwritings. Oh, that's it. Where's the mouse? Oh. Part 1 and literature. I'm not writing literature. Chemicals used. Equipment. I haven't seen this thing up here. What is this sinometer? Where is DeepSeek? I don't think this thing is mentioned up here. Pyrex bottle. Go. Let's see what this guy got. I mean, at this point, I could just copy from my old lab journal because that makes sense. You know, I'm not gonna give it everything. Let's take it slow. First part. Here, dichloromethane is used instead of the ether, saw as witnessed or seen on the extraction experiment. I believe. I believe. These comments are not useful up here. Just don't. The color intensity of the organic phase for both extraction. Iron has to be iron has to be destroyed before it is disposed. Therefore, treat all iron containing solution with sodium thiosulfate solution until they are colorless. Add only as much sodium thiosulfate until the solution becomes colorless. Then separate the aqueous and organic phase and dispose them separately. The colorless aqueous solution can be disposed in the sink. The colorless organic phase are collected in dichloromethane collection container. What? Then separate the aqueous and organic phase example and dispose them separately. The colorless aqueous solution can be disposed in the sink. The colorless organic. Okay. Okay, I get it. I get it. So I'll start writing the first part. So I don't wanna die young, I don't wanna fall. Uh Section 1, extraction and part 2. For what are the different single and multiple extraction? That's part 4. Preparation of solution. No, do I need to have this? Maybe. Makes it look a bit more professional. I start with part 3. Part 3. I need to listen to some music. Today no bouldering. I mean, I'm not happy I could be here. You know what I'm saying? You know what I'm saying? Oh, fuck me. Why is ink? Where is this ink leaking? From the tip of the fan? Maybe from the tip of the fan? No. It's not leaking. That was the most weirdest. Just play, goddammit. Come on. Part 3, part 3. For binary. Individual component volumes. Hydrogen bonding. To the volume. Contraction. Stop sweating. Part 4. The fuck, it's Cardi? Of course, it's Cardi. Not your ordinary. But Leah, with the moment we are. Close is closed. What do you mean if required? I do believe I have everything, right? Yeah. Page papers. Oh yeah. Page papers. Marker. That's something I like. These ball. It's the balls. It's the balls. I hate this song. Fuck this. Nah, bro. Oh no. This is a good song. It's a good song. Go while I begin till I reach the. I wanna triumph. Oh, oh. Try everything. Oh, oh, oh. I don't get. This is approximate sugar content. So, part determination of sugar content in the beverage. Each student determines the approximate sugar content of a beverage, measure the refractive index of the given beverage. So we measure the refractive index of the given sugar beverage, sugar containing beverage, and we'll find the answer for. Yeah. Dude, the song is amazing. Oh, I forgot to do one thing. What the? I'm sorry, people. I'm doing one stuff right now. Uh, so, beep, 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 beep. Well, people, YouTube, I'm gonna end the stream. I'll continue within some time. Okay. I'll continue the stream in a bit. I have to call my parents and be right back.